actually, I mean, they do a lot more in the book than I'm going to cover. For time consideration, the only thing from chapter 5, section 1 that I'm going to cover is an angle and the idea of a radian. You'll see like what a radian is. Basically, a radian is another unit of measurement for angles. I mean, you're probably used to degrees. You know, that I think that's used a lot in society degrees. So, you know, you might be used to that one already. Radians, though, turns out to be mathematically nicer. If you go on in the calculus, you'll see why. A radian is something that's good to know. So 5.1, I'm only going to cover these topics. Introducing what an angle is and radians. They do a lot more. Again, anything I skip, you don't have to know. For the class, I mean. All right, let me see. I get this. I know these notes I sent out as well. So you should have these also. Okay, so let's see. First, what exactly is, let me just see. Good, okay. Okay, so what exactly is an angle? Well, to get to that, first I have to define what a ray is. I mean, the definition is here. You can think of a ray as this. You take a point on the line, you're only looking on one side of the point, you know, to the right or to the left, and the other part you're not looking at, you disregard. That's really what I'm trying to say here. So you take a point on the line, so it looks like I'm taking this point here. Everything to the left, I'm disregarding. Now I'm only looking at what's on the right side. So it's basically, I mean, this is not really the best thing to say, but you could think of it as almost like half of a line. The problem is a line has infinite length, you know, so half of that really doesn't make sense mathematically. But hopefully this makes sense what I'm trying to say. What a ray is, what an endpoint is. And why is that important? Well, as you can see down here, when you take a ray and rotate it about its endpoint, you end up getting this picture, but you end up getting an angle as well. Namely, the idea is this ray here, I'm going to rotate it about its endpoint. When I do that, I'm going to end up over here. So this is kind of like the after picture, if you want, of rotating it. After I rotate it, I form an angle. An angle is really just a way of measuring. It's a way of measuring rotation, but it also indicates direction as well. So what happens is when I rotate the ray here about the endpoint, I get this. That's what this little green arrow I drew is trying to indicate. I rotate it this way. For the angle, we have the initial side here. So this is the angle's initial side. This is the angle's terminal side. This is the vertex of the angle over here. Now, I didn't draw it, so let me draw it now. But basically, for angles, we like to use Greek letters, such as this one. It looks like a circle, and you do this kind of symbol. It's a Greek letter, and it's called theta, Theta. That's a letter like that is what we use for an angle. You know, there's theta that we use. So again, this symbol here is theta. That symbol is what we use for angles generally. Greek letters. I mean, there's other Greek letters we use. Here's the first one. But this is what an angle actually is. So you get it by rotating about a point, rotating a ray that is. And it does indicate some kind of direction. I mean, if you go into Math105, which is pre-calculus, you'll actually see that if you rotate counterclockwise, which is what this is, the angle in what we call standard position is considered positive. If we went the other way, the angle would be considered negative. That's a little bit beyond what we're doing here, but I just wanted to let you know that the angle does indicate direction. Okay. But how do we measure angles? It's like, for instance, how do we measure length? We have units for that, right? We have miles, kilometers, meters, yards. Well, angles, how do we measure those? Well, there's two units, as I indicated already. There's degrees and radians. There is a definition of what a degree is. It is kind of like a little bit it's kind of like strange. I did write it down here, actually. A good way to think of it is this. 360 degrees, that's a full, complete counterclockwise rotation. Again, angles do have direction in them. When you rotate counterclockwise, that's understood to be positive. If I rotated clockwise instead, then it would be negative. The angle would be negative. It would be negative 360 degrees in that case. But that's what 360 degrees is. It's a full, complete counterclockwise rotation. Kind of like an about face that the people in the Army do, I guess. Like about face. Actually, no, I take that back. Get what I just said? So 1 degree then would be 1 over 360 of this complete rotation. Now, what does that look like? Honestly, to be accurate, if I wanted to draw it accurately, I don't know, but what I have here is enough. This is just notation that I'm using. This little circle looks like I'm raising it to a power, but it's really notation for degrees. So 1 over 360 of this, if you can somehow imagine that, I have not tried to, that's what 1 degree would be. What I was saying before about that about face thing, that would be half of that, which is 180 degrees. When you turn around, you're facing the other way, turning around counterclockwise, half of a full rotation, that's 180 degrees. That's what I'm trying to indicate here. Here, when you do 1/4 of that, right? So you start out this way, then you rotate, and now the terminal side is facing up. Then you have a 90-degree rotation. Okay, so that's what we have here for angles. That's for degrees. Now for radians, there actually is a formal definition of what a radian is. Okay? I didn't put that down because that definition would cause a lot more confusion than necessary. I mean, it's not terrible, but what I did put down here, as you can see, is how to convert between degrees and radians. And since we have 15 seconds left, I think I should stop. So